Problems 10 to 13. We're looking to solve an equation to find compound interest. We'll use the equation A equals P times the quantity 1 plus R over N all to the power of N times T. Okay, R is the interest rate in decimal form, N is the number of compoundings, T is the time in years, and P is the initial principal invested, and A is the final amount. So when we calculate this, for number 10, we're plugging in value A is equal to the initial amount, 2,500, times the quantity 1 plus the interest rate as a decimal, 12% is 0.12, over N, the number of compoundings for a quarterly compounding is 4, all to the power of 4 times the number of years, which is 10. So we'll go ahead and calculate this number, 2,500 times the quantity 1 plus 0.12 divided by 4, all to the power of. Since I have multiple factors in my power, I need to group it in a set of parentheses, and I get my solution to be about 8,155 and 9 cents. For number 11, the only difference between 11 and 10, here the principal amount is the same, the interest rate is the same, and it's still quarterly compounding. The only difference is the number of years is 20, and so when I calculate this, I simply need to change my 10 to a 20, and I get my solution, $26,602.23. Problem 12, I'm going to change some values. My initial amount of principal is $1,000. My interest rate is now 10%, which is 0.10. The number of compoundings is monthly, so that's a 12. And so when I plug that in for 10 years, these are the numbers I'll calculate. Go ahead and punch those into the calculator. 1,000 times the quantity 1 plus 0.1 divided by 12, all to the power of, again I have multiple factors in my power, 12 times 10. Close it off and hit enter, and I get my solution, $2,707.04. Problem 13 differs from 12, again, only in the number of years. So I still have 1,000 for the principal, I still have 10% and 12 compoundings. The only difference is this is 40 years for the T value. And so when I calculate, I simply need to change the 10 to a 40, and I get my solution, $53,700.66.